children, hope you are all safe at home. In chemistry, today we are going to learn a new lesson. What is the name of the lesson? We'll see. Elements. They not only play a critical role in chemistry but also in our day to day life. If you look around yourself, most of the things that you see they are ultimately made up of elements like carbon, hydrogen, sulfur, oxygen, and so on. They are exist more than 118 elements and still we are counting. Do you think that it is feasible to know the properties of these elements? Not really, and that is why we have grouped these elements based on similarities in their properties, and that's how we have got the periodic table, and that is exactly where we talk about periodic classification of elements. So the topic of this lesson is periodic classification of elements. Let's have a detailed look at this modern periodic table. We'll study periodic table, history of periodic table, modern periodic table, Mendeleev's periodic table. We will also study trends in modern periodic table. We'll start with our topic periodic table. The history of periodic table. Introduction. The 18th and 19th centuries witnessed a rapid development in chemistry in all spheres of scientific activities. By 1860, scientists had already discovered 60 elements and determined their atomic masses. They noticed that some elements have similar properties and hence arranged them into groups. During this period, several new elements were discovered. These elements were found to have different properties. It was realized that instead of studying the properties of all these elements individually, it would be more convenient to divide them into groups and periods in such a way that each group contained a certain number of elements, like an array of fruits and vegetables, showing orderliness. See this table column with similar properties and periods showing a regular gradation. So scientists made several attempts to arrange elements in a logical way. You have studied about all these early attempts of arrangement of elements in Standard 9. In continuation of the knowledge gained in the topic periodic classification of elements in Standard 9 with earlier concepts and their subsequent deliberations, you get set to go ahead with the higher order of thinking to enhance your knowledge on the properties of elements. Modern periodic law. Mendeleev's periodic table had some discrepancies which were difficult to overcome. For example, the atomic mass of argon 39.95 AMU. What is AMU? Atomic mass unit is greater than that of potassium 39.10 AMU, but argon comes before potassium in the periodic table of elements were arranged solely according to increasing atomic mass. Argon would appear in the position occupied by potassium in our modern periodic table. The fundamental property turned out to be the number of protons in an atom's nucleus, something that could not have been known by Mendeleev and his contemporaries. Periodic table of the elements. In the late 1860s, Mendeleev began working on his great achievement, the periodic table of the elements, by arranging all of the 63 elements then known by their atomic weights. He managed to organize them into groups possessing similar properties. Where a gap exists in the table, he predicted a new element would one day be found and deduced its properties. And he was right. Three of those elements were found during his lifetime: scandium and germanium. They provided the strongest support for his periodic table, a cornerstone both in chemistry and in our understanding of how the universe is put together. Atomic number of an element refers to the number of protons in the nucleus of an atom. The number of electrons in the neutral atom is also equal to its atomic number. Henry Moseley, a British scientist in 1912, discovered a new property of elements called atomic number, which provided a better basis for the periodic arrangement of the elements. It is a well-known fact that atomic number of an element is equal to the number of protons or the number of electrons present in the neutral atom of an element. The periodic law was therefore modified to frame a modern periodic law, which states that the physical and chemical properties of the elements are periodic functions of their atomic numbers. See, helium symbol He. Above the symbol atomic number, for helium atomic number is 2. Below this is symbol atomic mass number. For helium atomic mass number is 4. Look at this periodic table, now arranged by an increasing atomic number law. When elements are arranged in order of increasing atomic number, there is a periodic repetition of their chemical and physical properties. The modern periodic table. What are columns called? Columns are called as groups. What are horizontal rows called? The horizontal rows are called as periods. Arrangement of the periodic table. Groups. Similarity in physical properties, families, columns up and down. Arrangement of the periodic table in periods. Properties change in pattern shows a progression rows across. Features of periods. Horizontal rows are called periods. There are seven periods in the periodic table. The first period, second period, this one is the third period, this is the fourth, this is the fifth, this is the sixth period, this is the seventh last period. First period. First period, atomic number from 1 and 2. This is the shortest period. It contains only two elements. See, this is the first period. It contains only two elements. First one is hydrogen. The symbol is H and the atomic number is 1. The second element is helium. The symbol is He. The atomic number is 2. This is the shortest period. The second period. This is also the shortest period. It contains 8 elements from lithium to neon. This is the second period. The element from lithium to neon. The atomic number is from 3 to 10. The third period, this is also a short period. It contains again 8 elements from sodium to argon. The atomic number from 11 to 18. Now fourth period, this is the fourth period. It is a long period. It contains 18 elements from potassium to krypton. This includes 8 normal elements and 10 transition elements. For potassium, the symbol is K. The atomic number is 19. To krypton, the symbol is Kr and the atomic number is 36. So the fourth period, atomic number from 19 to 36. This is the fifth period. This is also a long period. It contains 18 elements from rubidium to xenon. The atomic number is from 37 to 54. Rubidium, the symbol is Rb. Xenon, the symbol is Zt. This is the fifth period, the atomic number starting from 37 to 54. This is the sixth period. This is the longest period. It contains how many elements? 32 elements from cesium to radon. The symbol for cesium is Ca and the radon is Rn. The atomic number for cesium is 55 and the radon is 86. So the period from cesium to radon is the sixth period. This includes 8 normal elements, 10 transition elements and 14 inner transition elements, that is lanthanides. What is this IUPAC here? International Union of Pure and Applied Chemistry. Groups. Elements with similar chemical properties that lie in the same vertical column are called groups. Groups are often referred to by the number over the column. Example: fluorine, chlorine, bromine and iodine make up group 17. Fluorine, atomic number is 9. Chlorine, atomic number 17. Bromine, atomic number 35. Iodine, atomic number 53. Astatine atomic number 85. Going down group 1, the size of atom increases. Going down group 1 element, the number of shells occupied with electron in the atom increase. The size of an atom increase. Features of groups. See this periodic table. The vertical columns in the periodic table are called groups. Starting from top to bottom are called groups. How many groups are there? There are 18 groups in the periodic table. This is the period. How many periods are there? There are 7 periods. Based on the common characteristics of elements in each group, they can be grouped as various families. First group is alkali metals, second one alkaline earth metals, third from 3rd to 12th transition metals, the other metals. These are the comes under metals. Another one is a non-metals. This one semi-metals. This is the halogen groups, non-noble gases. Last one 18th and other non-metals. See this tabular column, group number and the corresponding family name is there. Group number from first group to 18th group. First group family name alkali metals. Second group family alkaline earth metals. Third group to 12th group transition metals. 13th group boron family. 14th group carbon family. 15th group nitrogen family. 16th group oxygen family or chalcogen family. 17th group halogens. 18th group noble gases. The lanthanides and actinides of which form part of group 3 are called inner transition elements. Except a zero group, all the elements present in each group have the same number of electrons in their valency shell and thus have the same valency. For example, all the elements of group 1 have one electron in their valency shell. That is 1 as 1. So the valency of all the alkali metal is 1. As the elements present in a group have identical valence shell electronic configurations, they possess similar chemical properties. The physical properties of the elements in a group such as melting point, boiling point and density vary gradually. Next, the atoms of the zero group elements have stable electronic configuration in their valency shells and hence they are unreactive. Why is it called a zero group? Why is a zero group not called group 8 even though it comes after group 7? It is used to be called group 8 and still is in some cases. See here. In the rest of the periodic table, the number of the group is the same as the number of outer shell electrons in the elements of that group. However, this is not true for the noble gases. Helium only has 2 electrons in its outer shell while the others all have 8. Next, because of this, the group's number was changed to 0. Trends in the groups from left side most likely to lose electrons. From group 1, it can lose 1 electron. Group 2 can lose 2 electrons. Group 3 can lose 3 electrons. Next, right side, it gains electrons. Group 17, it gain 1 electrons. Group 16, it gain 2 electrons. Periodic trends and properties. The electronic configurations of elements helps us to explain the periodic recurrence of physical and chemical properties. Anything which repeats itself after a regular interval is called periodic, and this behavior is called periodicity. Some of the atomic properties of the elements are periodic. Properties such as atomic radius, ionic radius, ionization energy, electronegativity, electron affinity shows a regular periodicity, and hence they are called periodic properties.